Exactly. If you plug in t, you're going to get the square root of -1. So what Alex says is 9 minus x must be greater than or equal to 0. Now, when you solve that, you subtract the 9. Negative x is greater or equal to -9. Divide by the -1. X is less than or equal to 9. So we go from -infinity to 9. How about the next one? What's wrong with that? What? Can't be 2. X can't be 2. Because you can't have 0 in the denominator. Next one, you can't divide by 0. What's going to give us 0 in the denominator? Well, we better factor it. X minus 3, x plus 2. So x can't be -2 or 3. You guys are really good at things if I tell you what to do, and then you just repeat it and go on and go on and go on. It doesn't work in this situation. You have to think about every problem. So all of a sudden you see a radical, and people say 2x plus 5 is greater than or equal to 0. Right? Why? What about cubed root? Because you could cube root a negative. So therefore, all real numbers, -infinity to infinity. Now we get to one that's challenging. You see the square root. You know you can't take a square root of a negative. 9 minus x squared must be greater than or equal to 0. 9 minus x squared must be greater than or equal to 0. You have an inequality that involves a squared. Anytime it's not a linear inequality, meaning the first degree, you got to consider the graph or look at the table. Do you know what this graph looks like? Bravo, raise it up or upside down. What are the x values it goes through? -3 and. So are we wondering where that's above or below? Above. That means you take any number between -3 and 3 and you plug it in, you're going to get an output. But if you take any number outside of that interval, -3 to 3, and you will not get an output. You try the last one on your own. Talk with a peer to see if you can do something with it. Tell me something, anything about the last one. Why can x not be 0 or 1? Yeah, you can't divide by 0. What would give you 0 in the denominator? 0 or 1. So x cannot be 0 or 1. But now I have a square root in the numerator. X has to be greater than or equal to 0 if you consider the numerator. So these two are in conflict with each other. Everybody agree that those two are in conflict with each other? Yeah, so I've got to make those kind of work out together, okay? So I've got to go from 0 to 1. And the fact is, I can't be equal to 0, and I can't be equal to 1, but I want everything that's greater than 0. So that's the type of graph that you're trying to express an interval for. And so we're going to go 0 to 1, union with 1 to infinity. There you have it. Okay, so that domain assignment from yesterday, again, my word of caution, I would expect at least a third of people are going to need to ask some significant questions on that, because usually that's when it causes problems for people. So make sure that you're finding a way to come on and see me and ask questions if you have them. We move on to graphs of functions. Given the graph of the function f, identify the following: f of -2, f of -1, f of 0, f of 1, and f of 2. That means if you plug in an x value of -2, what's the corresponding y value? If you plug in -2, what's the corresponding y value? 1. Yeah, the height of the function is 1 right there. What's f of -1? Is it 1 or 0? Is it both? It can't be both, because the definition of a function is every input has exactly one output. So is it 1 or is it 0? Yes, because you have the closed circle. F of 0. What's the height of the function at 0? It's 1. What is f of 1? -2. And f of 2? 1. Find the domain and range of f. Again, we're practicing what we did yesterday, then we'll move on to new pieces. The domain of this function, what I do is I take a vertical line and I drag it across. You can see that the graph is going to cross over here at any values that are negative. So we have negative infinity, and I drag it across, and it still has a value here at -1. Still has a value here at 1, and it goes all the way across. So you can see my domain is from negative infinity to positive infinity. Then the range, I drag that horizontal line. I start down here. Is the graph going to cross down here? Yeah? How about here? How about here? 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 No. So it looks like it goes from negative infinity to 2. And not a bracket, a parenthesis. Then finally, the third question, find the domain values that satisfy f of x is equal to 0. F of x equals 0. Is 0 an x value or a y value? It's a y value. So as you check this out, if I place this at a height of 0, the question is, what are the x values that will produce y values of 0? What are they? -3 and 4. X equals -3 and positive 4. Flip it over. We want to use the vertical line test to determine if something is a function. If the vertical line crosses the graph in more than one place, that means that there are 2 or more outputs for every input, and that's not a function. So is this first one a function? Yes. This one? This one. Why? So how many times does it cross? An infinite number of times. So this fails to be a function. Yes. So, yes, no, no, yes. Sometimes you don't actually have the graph, you have an equation. You want to be able to determine, is this equation a function of y in terms, or a function of x in terms of y? How do we do that? Solve for y and see what happens. I have -4y is equal to -2x squared plus 8. Divide by -4, and we have y is equal to 1/2 x squared minus 2. Give me a number. 3. Ugh. 4. 4 squared is 16 times 1/2 is 8 minus 2 is 6. You plugged in 4, you got 6. You give one input, it gets one output. Agreed? This is a function. The next one, sometimes you can tell just by looking at it. What shape does this make? Circle. Is a circle a function? Let's show it's not by solving for y. Y squared is equal to 9 minus x squared. I square root both sides. When I square root a variable that has a squared, I have to list the positive and the negative. Now watch what happens if I plug in a value for x. I'll plug in 0 for x. 9 minus 0 is 0, and the square root of 9 minus 0 is 9, square root of 9 is 3, and it says positive 3 or negative 3. Well, that says that I have an input that gives me 2 different outputs. You can see that when you get a y is plus or minus, or if you have a y squared, it's generally not going to be a function. So that is not a function. You get 2 outputs for every input. And we knew that because it's a circle. The last one is a cube root. Negative y cubed is equal to negative x minus 3 as I move everything over to the right other than the y. Multiply through by -1, y cubed is x plus 3. And then when you get rid of a cubed root on a variable like y, you do the cubed root, you don't have to list all 3 solutions or 2 solutions or positive or negative, just y is equal to the cubed root of x plus 3. As you try to think through it, I'll pick a value, I'll pick 5. As I plug in 5, 5 plus 3 is 8. What's the cubed root of 8? So I only get one result. It's not like it's saying that you're going to get multiple results from that situation, okay? So we're going to pause there. You're going to get about 7 minutes to work on your assignment, and then we're going to do this last section. sorry, YouTube. There we go. In order to finish the assignment, you got to be able to graph piecewise functions. And so this is kind of new learning for you. And this is something people throw aside. And then all of a sudden you get these wrong on the test and you take a whole grade lower then, okay? So say 6 points of the test are devoted to this. The test is 60 points, it's minus 10% right away, right? Number of people will get to this, they get it wrong, they tell me later, like, Mr. Getz, I never actually learned how to do that. Folks, you have many opportunities to work through the confusion here. We're going to do some checkpoints for make sure you have an opportunity to learn what you're doing. But I've spent a number of years teaching this, and this is the best way I think to do it. If you find a different way, go ahead. Do not write what I'm going to write right now, okay? I'll wait. I'll show you when to start drawing. You have f of x is equal to 3. That's y is equal to 3. And you have f of x is x minus 4. That's y equals x minus 4, okay? What does the graph of y equals 3 look like? Horizontal line through 3, right? And the graph of y equals x minus 4? A line goes through -4, slope of 1. Agreed? So if I put both of those on the graph, that is not a function anymore, is it? It does not pass the vertical line test. So here's what we need to do. We need to keep that picture of those graphs in our mind, but we don't want all of them. You see, it says that when x is less than 2, we want this graph. We want this graph right here. We don't want it after 2. And then when x is greater than or equal to 2 on this side, then we want this graph. We don't want it back here. You see that? So what we really want is we want this picture. That's what we want to try to produce. But we would like to do it without all the scribble and everything on there. You know what I mean? So here's what we do. We keep that picture of the graph in our mind, and now we can start writing stuff down. We figure out where the break happens. The break happens at 2. I plug in 2 to the function. If you plug in 2, what do you get? 3. So I plot a circle. Do you think the circle is going to be open or closed? Open. So 2, 3, open circle, and you can see that it heads on off to the left. You remember that graph, right? So I just draw that portion. Then I plug in 2 for the bottom. When you plug in 2 for the bottom, what do you get? -2. Open or close circle. Now, a lot of people say, okay, you got to go through -4. I don't want to go down there, right? I got to draw it to the right of 2. So I draw it with a slope of 1 headed this way. You don't want to draw this portion here. And that's my graph. That's all there is to it. A piecewise function. We try a second one. What does x plus 3 look like? Line at 3 with slope of 1. Good. X squared. Parabola centered at 0, 0. Does everybody have that picture in their brain? Okay, that's what you got to picture in your brain to start off. Now, we got to see where we have the dots and the break. So I plug in -1. When you plug in -1, what do you get? 2. Open or close circle at -1, 2. Close circle at -1, 2. How do I draw it now? Yeah, very good. Some people say we just drew negative slope. This is positive slope. We measure slope left to right. Left to right, we're going up. That's positive slope. That's a slope of 1. Okay, then plug in -1 for the bottom. When you plug in -1 for the bottom, what do you get? 1. So -1, 1. Open or close circle? Open. Where do I draw it from there? Down to 0, 0, and then up. That's the graph of the piecewise function. The last one. 4 minus x squared. What does that look like? We know it's a parabola. Upside down. Up 4. Good. -2 looks like that. and x minus 5 looks like that. Got those three thoughts in your brain? Because that's what we're going to use. We got to now section them. So I plug in 1. We plug in 1, what do you get? Open or closed? And where do I draw it from here? Okay, I go to the left. I go up to where? 4. And you maybe figured out it does have an x-intercept of -2, so that could give you another point that you can draw it through. So that would be a really good picture. Like if you did that on a test, you'd be like, oh, wow, that person takes their math seriously. I like it. Then I plug in 1, and you get -2. And then you plug in 3, and you get -2. So I got 1, -2. I got 3, -2. And I join together. Open circles. Last one, I plug in 3, and you can see we get -2. Now, if there was an equal sign there, we would then fill that spot in. But it still says just greater than, so I don't fill that spot in. So I've already got 3, -2. Now I head on off with a slope of 1, it says. So there I have a slope of 1. So that's the last piecewise function. So on the back of your assignment, you have 6 problems of graphing piecewise functions. Okay, make sure you take a look at that. On Friday, you'll be working on your study guide for the final exam, as well as next Tuesday.